Alright, so the next thing we look at is angles of elevation and depression. So angles of elevation, just think of it as if you're looking up, and that's the angle it makes. So you're looking up. So depression, just think of it as you're looking down. So the hardest part about these questions usually is getting the diagram right. But yeah, a key thing to remember is angles of elevation and depression, they're sort of the same thing because of alternate angles. So you'll see when we do the examples. Alright, so the first one, so Luke walked 100 meters away from the base of a tall building on level ground. He measured the angle of elevation to the top of the building to be 62 degrees. So yeah, so the key bit is getting the diagram right. So just say that's our tower. So you might have drawn the triangle in reverse. It doesn't really matter. So we know that that's 400 meters, and when he looks up, it's 62 degrees to the top. So pretty much what we're trying to find is the height of the building. So if that's our building, that would be the height there. So yeah, basic right angle trig. So you've got opposite and adjacent, so it's going to be 10. So opposite is h, adjacent is 400. So we know that this is going to be 40, 10, 62. And then yeah, we just type it in our calculator. And you should get 752. And I'm just going to go to 2 decimal places. Doesn't really matter because it doesn't say in the question. Alright. So the next one. So now it's the angle of depression from the top of a TV tower toward a satellite dish. So that's our tower there and the satellite's on the bottom. The angle of depression is 59 degrees. So that's the angle there. So we know that due to parallel lines and alternate angles, that'll be 59 here as well. We know the dish is 70 meters from the base of the tower, so that'll be 70 here. And we're trying to find the height, h again. So it's pretty much the same thing as above. So it's another 10. So tan 59 equals h over 70, and h equals 70 tan 59. And you should get roughly 116.50 meters. So that's the 2 decimal places. So you guys can try the next 2 questions. So the next thing we look at is the exact values for 30 degrees, 45, and 60 for sine, cos, and tan. So you're pretty much expected to know these off by heart, but there's a little memory trick we can use. So the first one is, think of an equilateral triangle with sides 2. So if you cut it in half, the angle goes to 30, and then that bottom side will go to 1. And then we know equilateral triangles have 60-degree sides, and then you can use Pythagoras to get that third side. And then same thing, think of a square with sides 1, and then you cut it in half, so the angles go to 45, and you can use Pythagoras to get that last side. So yeah, you can use these triangles to help you memorize these exact values here. So yeah, so if you notice, sine theta equals 1 over root 2. If you go to the triangle, so sine theta is opposite over hypotenuse, so 1 over root 2. So it works for all the angles that you need to know. So this one, find the exact value of cos 30 and sine 30. So from our table, we know that cos 30 is root 3 over 2. And we know sine 30 is a half. So yeah, we can either leave it like that, or we can write it as root 3 plus 1 over 2. Doesn't really matter. Alright, so the next one, sine 30 is a half. And then cos 60 is also a half. So if you remember our complementary angles, sine 30 and cos 60 are the same. So half plus a half goes to 1. Alright, so this next one, so you have this triangle, show that x equals 10 root 3 minus 1. So pretty much we need to find x, so we need to know that this little side here is a, and we just call the whole thing b. So if we're looking at the small triangle, we have opposite and adjacent, so tan 45 equals a over 10. So a equals 10 tan 45. So since we know the exact value for tan 45, we can just sub it in. So now tan 45 is just 1, so it's just 10 times 1 is just 10. If we look at the big triangle now, if you add the angles together, it's 60. So tan 60 equals b over 10, and b equals 10 tan 60. So we know tan 60 is root 3, so it's just 10 root 3. Now since we need to find x, x is just b minus a. So x would be 10 root 3 minus 10. And if we factorize that, we get 10 and then root 3 minus 1, which is what the question wants. So next we have bearings. So compass bearings, so north or south is always written first, and then the ray is measured from them. So this one here is north 30 degrees east. So this bottom one here, south, and then 70 degrees east. So it's always measured from the north or the south line. So true bearings, so it starts from true north and it goes clockwise around. So if these two are the same diagrams, we know that that's 30 in there, so it's going to be 30 degrees here, true north. So you're still in the other one, we know this there, so we know that's going to be 70 there, so we know that inside here is going to be 20. because of right angles. So that means if it starts then goes around, so it's 90 plus that 20, so it'll be 110 degrees here. So now that's 45, so it would be 180 plus 45. So we get 225. Remember, it goes around to 360. So if we know that's 20 there, so 360 minus 20, we get 340. So yeah, so the first one's compass bearings, the second one's true bearings. Alright, so now we're going to do a problem solving question. So as before, the hardest part is trying to understand the picture. And yeah, this question is a bit badly worded as well, so I'll help you guys through with it. Alright, so a plane flying at 400 kilometers per hour flies from A to B in a direction of south 30 degrees east. Alright, so just say, I might change color here just to make it easier. Alright, so say that's A there. So it goes south 30 degrees east, so that's in that direction, so that's 30 degrees there. And it flies for 15 minutes. And it goes up 400 kilometers an hour, so 15 minutes is a quarter of an hour, so a quarter of 400, so that's going to be 100 kilometers there. The plane then turns sharply to fly east for 30 minutes to C. So that's point B, it goes east to C. So it goes for half an hour, it's half an hour, you use 200 kilometers. Alright, so part A in this question, it wants you to find how far south and east separately of A is point B. So I want you to find this bit there. Then I want you to find how much it goes across. So we have to find them separately. So yeah, we might call the south bit Y and the east bit X. Alright, so now we have our diagram. We can see it's just a right angled triangle, so we know that's 30 degrees. We know hypotenuse is 100. So let's find X first. So X is, we have opposite and hypotenuse as sine. So X equals 100 sine 30. When an exact value of sine 30 is a half, so 100 times a half equals 50. So let's do Y. So Y is adjacent over hypotenuse, so it's going to be cos 30. And we know cos 30 is root 3 over 2. So 100 divided by 2 is 50, so it's just 50 root 3. Alright. So now for the second part of the question, we want you to find the true bearing of C from the point A. So first we're just gonna join that up here. So it wants us to find that angle there. So to help us, we know that if we find this angle here, it'll equal this angle there. And then to find the bearing, it would just be 90 plus theta. So if we look at theta, we know this is the right angle triangle. So we can find that by doing opposite over adjacent. So it's going to be 10. So opposite y is what we found in the first part. So it's going to be 50 root 3. And the adjacent, so x is 50 plus that 200, so it's going to be 250. So find an angle, so make sure you use the inverse. So inverse 10 of 50 root 3 over 250. So you can tell that 50 over 250 does simplify to 1 over 5, but since we're typing the calculator anyway, I'm not going to bother too much about simplifying it. And to the nearest degree, that gives us roughly 19 degrees. So that means bearing is 90 plus 19. So that'll be 109 degrees. True north. So yeah, that's that question. And we'll just do one more question. So remember, the hardest part is getting the diagram. So port Q is 45 nautical miles from port P on a bearing of 55 degrees. Then port R is 65 nautical miles from port P and angle PQI equals 90. Alright, so let's just start. So we'll start off with P first. Alright, I might switch colors again. Alright, so if we start off with P, we know that on a bearing of 55 degrees, that's where Q is. So that's 55 degrees in there. And we know that that distance is 45 nautical miles. And then angle PQR, so PQR is 90 degrees. And then we also know that the distance of P and R is 65. Alright, so part A is find angle QPR. Alright, so we know that we have this side there, so that's adjacent, so that's the angle there. Adjacent and hypotenuse, so that's cos. So remember, read the question carefully because it wants it to the nearest degree. So do it on the calculator. You should get roughly 46 degrees. And B is find the bearing of R from point P. So that's pretty much that whole angle there. So it'll be 55 plus the 46. That gives us 101 degrees.